we have done in the last class. So we were discussing this third block, that is third block of the communication, digital communication setup, bit to waveform mapper.
Just before we start, just one procedural question. Sorry. By any chance, can you give us insight whether Nielsen equation is with Nielsen?
हमेशा ही होता है. There is no, I mean, there is always some part of the mid sem which is asked in the end sem. The weightage might be less, but it is always there. Anyways, so this is the source encoder. Let's represent it by the abbreviations source encoder. This is the channel encoder. So here we get sequence of bits, right? Here also we get sequence of bits, but channel encoder introduces some redundant bits. So here also we get sequence of bits, and next our aim is to transmit this information or communicate this information, therefore through a channel. Therefore we convert this sequence of bits to some form of waveforms. So we were discussing this block, right? So in the last class we have seen a very generalized procedure, but today we will see the, okay, before going to this, let's try to solve this numerical. So we have a 4 symbols, and we map it to waveform, 4 different waveforms, which can be composed by using these 2 orthonormal bases. And if we represent those points, those 4 waveforms using this, so we can put like this, that so this is maybe corresponding to 0 0, this might be corresponding to 0 1, this might be corresponding to 1 0, and this might be corresponding to 1 1, or this might be 1 1, and this. So what is the value of S? How would you represent S1? S1 is, you have to ask what is the value of this. So if this value is A and this value is A, similarly all are like this, A my A. So you will write S1 as A phi 1 t plus A phi 2 t, right? Similarly, you can also write t here, S2t as minus A phi 1 t and A phi 2 t. So you can write S1 t as S1 vector as A comma A, and these 2 are its basis. There is one more notation, vector notation, right? You can use it. S3t क्या होगा? What would be S3t? No, minus A phi 1 t and minus A phi 2 t, not same. So S4t would be, what would be S4t? A phi 1 t minus A phi 2 t. Fair enough. So the question is, what is the average energy or power of this constellation. This is called constellation diagram. So, this constellation, look at this constellation and tell what is the average energy given all symbols are equiprobable. How would you do that? What 0? So, this is the question which is asked, that what is the average energy or power, let us say energy, so energy of this average energy of this constellation. What would be the average energy of this constellation? Batao. See, this is S1T, S2T, S3T, S4T. So, first you need to find out what is the energy of S1T. How would you find out? Not infinity, you have to write the time duration over which you are communicating, right, because these all waveforms are present only between 0 to t, correct? Yes or no? Right. So, if you solve it, what would be the value? All of you please solve it. Please let me know if any of these steps is not clear to you. I hope all of these steps are very trivial. I have just applied some a plus b whole square or x plus y whole square, that is x square plus y square plus 2ab, right. So, we know what are the properties of the basis functions, that they are of unit energy and all of them are mutually orthogonal. What do we know? We know that each basis function is of unit energy and they are mutually orthogonal. So, by using these two properties, here energy of S1T, what would be energy of S1T? Would be a square t plus a square t, this will be 0 plus 0. Yes or no? I think energy, do we take नहीं सही बोलो. कहाँ पर? Which one? This? यहाँ पर?
So that phi1 square t will become
0 to t phi 1 square t dt. yes, because a square is constant. So you have to take a square outside, and then you will have these two integration, and by applying the property of the orthonormal basis here, you will get that this is the energy. So if you see, the power would be a square plus a square, right? T would be going. So that is why I have written here energy or power, because you will get any of that. So 2a square t, yes or no? One second, no, the t would not come into picture. I now understand what was the confusion. It's my bad. Yes. So this correct. So the energy is 2a square. ठीक है? So if you see, I have also told you in the last class that actually this gives you root of its energy. The distance of a constellation point from the origin is the square root of its energy. नहीं, you can see from here na, a square phi 1 square t, a2 square phi 2 square t. So whatever is the projection of this over this a, what is the projection of this over this a, square and then square root, right? So energy is, what would be the energy? If this value is square root of its energy, right? So energy will be d square, and d1 is under root a square plus a square. Right? So there is no need to do all of this. If you know the distance of each constellation point from the origin, you can directly evaluate the energy of each of this waveform. So what is the energy corresponding to waveform S1T? Just look at the distance of this constellation point from the origin and square it. Similarly, what is the energy of this E2? If E2 is the energy of this point, क्या होगा? Same होगा. Very good. So 2a square, this distance is under root 2a square, therefore energy of S3T is also 2a square, energy of E4 is also 2a square. So now the question has asked average energy. So average energy.
So one question.
Hmm.
In other quadrants, the constant A has different signs, right?
But sign would not matter because you are squaring it here. Even though it has minus a,
Right.
because of this square, nothing would change. So what we have seen that whatever is the distance of this S1 vector, if S1T is a waveform, you can also write it as a vector form, right? So it's also in some book you can now write energy of ith constellation point. If you represent that by SI, it's vector norm. वेक्टर नॉर्म क्या होता है? इट्स डिस्टेंस फ्रॉम ओरिजिन. ठीक है? वेयर एस आई ये S1i क्या है? प्रोजेक्शन ऑफ दिस SI ओवर द फर्स्ट basis. This is the projection of. So, if any general point I say that this is phi 1 t, this is phi 2 t, and this is any general SI vector, right? कैसे होगा? S1i, S2i, which component is S1i? Means S1i is the projection of this over this, or the x component or the horizontal component, and this is the S2i. So, what would be the distance? Under root this square then this, and norm of SI is defined as the S1i square plus S2i. ठीक है? So, in some books you can also find that energy of the constellation is same as norm of SI, vector norm. This is called vector norm. And what is vector norm? Vector norm is its distance from origin. And how do you represent it? Like this. If SI is a vector with component, vector means array in your terms or in layman terms, though a vector has in abstract maths a different definition, but for now you can think of it as an array. Anyways, so now I hope the things are clear. So if you have 4 such constellation point in our example, so you will have 4 such values, and coincidentally in this example all of this is same. So, energy of all the waveforms is 2a square. ठीक है? So, now you can see how each waveform can be geometrically represented by a vector. That you appreciate or not? What was your SIT? बताओ, ऐसे था ना? You can write this in a vector form like this, where ai is the weight of phi 1 t, bi is the weight of phi 2 t, or in other words projection of Si over phi 1 t and projection of Sit over phi 2 t. And for this become a vector, and this is a waveform. So, you can represent each of this waveform as a unique vector, yes or no, over this basis. So, once you have done, I told you how to find out the energy of each constellation point. So, now you have energy of each constellation point, and therefore, energy of each waveform. You can easily evaluate average energy if you know what is the probability distribution of each waveform, meaning that if you see how many times this signal is sent, how many times S2t is sent, how many times S3t is sent, because from this bit to waveform mapper sometimes S1t would come out, sometimes S2t would come out, and so on. So, you will ask, when I asked this question, I told you that all symbols are equiprobable, all waveforms are equiprobable. So, you would say 1 by 4 times phi 1 will come out, therefore, the energy would be E1, this is average energy, plus 1 by 4 times E2 will come.
This is weighted average, okay?
Yes, weighted by their probabilities. This is called average energy. So, in our case So, what is the average energy of this constellation? Average energy of this constellation is 2a square, because we have put E1, E2, E3, E4 here. Understood? Yes or no? So, first we have seen that if you have a set of waveforms I is equal to 1 to how many? 2 to the power if you are taking 2 bit at a time, then how many waveforms will be there? 3 bit at a time, then how many waveform will be there? And you have converted this to, you have applied Gram-Schmidt procedure, you have converted it to some n number or some, what was the notation we have used in the last class? Anyway, so this is the number of waveforms, total number of waveforms. This will be this or this, right? Yes or no? So, each SIT can be represented using, bolo, S1I, S2I means projection of SIT over phi 1, phi 2 up to how many? N. Very good. And here you can write your all the.
Sir, in this case, what is K?
K is number of bits you are taking. 2 bit you are taking at a time, so 4. 3 bit you are taking at a time to 8. 4 bit you are taking to M16. That is why. You understood or not?
Yes, sir, I understood. So what could be the maximum value of n?
This maximum value of n can never be more than m. It will be less or equal to m, because you are representing s with minimum number of orthonormal bases. ठीक है?
For all of the 2 combinations, you can get one basis. That can be the worst case.
Yeah, it can be a scenario where all the SIs are linearly independent. If you know the term, then you can not do much. I mean, you can, but you can just orthogonalize, but you cannot reduce. See, dimensionality, you can think it like that. If you are in a dimension where 2 bases are required to represent that, for example, or if you are in a dimension, okay, I think I should not go to that, Abhishek, it would unnecessarily confuse you. So, let us be it here. Yeah, it is clear. Okay. So, we were discussing the concept of average energy, and while discussing the concept of average energy, we have seen that energy of S1T is same as the norm of that vector square, where norm is the distance of that vector from that origin, and where this vector comes from this analogy that if SIT can be represented by the set of bases, how you can represent this SI as a SI vector, SIT as a SI vector, where SI vector has components or weights of the corresponding bases. ठीक है? So, this we have seen through this example. So, let us take an example, and just you have to tell quickly what is the corresponding energy. So, we are now creating one more. Here the basis can be something else, and these are the constellation points. So, the points are something like that, that this is minus root 3a, this is root 3a. So what would be the energy? And this point is 2 root 3a. What would be the energy? Average energy of this constellation. So I would ask two questions. First, represent each waveform, represent or write equation of each waveform. Then second, evaluate energy of each waveform, calculate energy of each waveform. Then third, find out the average energy of the constellation assuming all are equiprobable, assuming all points are equiprobable. So solve it. So what would be the equation? S1t, you can write it as, because S1 vector S1 and equivalently, sorry, this is a S1 vector. So first you have to write what is this S1 coordinates, 0 0, very good. Therefore, you can equivalently write its corresponding waveform as 0, phi 1 prime t plus 0 phi 2 prime. Yes or no? Next, S2. So what is the corresponding points? That you have to look at it. So it is root 3a and yes, it is in middle, yes. So root 3a over the same basis. Therefore, the corresponding waveform would be root, क्या चीज़ ये कि ये मिडिल पे है, सिमेट्री से पता लग रहा है ना बेटा. अरे ये लिखा यह है ना रूट 3 है, क्या बात करते हो? नहीं दिया है, करेक्ट. बट सिमेट्री से इफ सच इज द केस यू कैन ऑलवेज एज्यूम, राइट, यू आर राइट. सो रूट 3a, but to the best of our effort we try to give everything, but if something is missing you can assume, always assume. So root 3a phi 1 prime t root 3a phi 2. Yes. Similarly, you can write for S3 and S4. Just quickly write it. And of course, you should always write t from 0 to t. बताओ S3 क्या होगा? Since your S3 vector is 2 root 3a comma 0, therefore the corresponding waveform would be equivalence. This is the sign of equivalence, right? Equivalently, you can write this as a, because it is just a notational thing, right? Physically these two things are same, right? Just notation for the mathematical. So this would be your easiness. We do it for mathematical easiness, we sometimes take different notations. Anyways, so S3t is this, right? So from, if you look at the constellation point, you can easily say what are the 4 waveforms you are going to send corresponding to. So you can map 0 0 to this, 0 1 to this, 1 0 to this. This is a separate issue how you are mapping, but these are the 4 possible waveforms which you are going to use. So S4 will be, I think, 0 and minus 2 root 3a, right? No, 0 root minus root 3a, sorry, only minus root it will be minus root 3, sorry, yes, root 3a and minus root 3. Very good. So, the corresponding S4T waveform you can write like this. Right? Always mention the corresponding domain, right? कि t कहाँ से कहाँ तक है. You should always, this is called complete representation. Anyway, so these are the 4 waveforms which you are going to send. So, what was the next?
Hide that checks.
Yes, sure. Okay, so the next question is calculate energy of each waveform. So, I have already told you that if this is a constellation diagram, energy of S1 will be the square of this norm. Energy of S1 will be vector norm of S1 square, and what is this vector norm? Its distance from origin, so therefore the 0. The energy of S2 waveform would be norm of this vector S2 square, and this is the distance of this. So, क्या होगा? Root 3a, this is root 3a, this is root 3a, right? Yes. So, 6a square, just check it. This is root 3a, this is root 3, sorry,
Okay, got it.
क्या प्रॉब्लम, ठीक है ना, 6a स्क्वायर, दिस इज 12a स्क्वायर, नहीं, हाँ सही है. द एनर्जी ऑफ दिस इज डिस्टेंस और नॉर्म ऑफ S3 होल स्क्वायर इज द एनर्जी ऑफ E3. So, this is the distance from origin is 2 root 3a, so square would be 12a square. Similarly, you can find the energy of the 4th point or the 4th waveform as the, which is I think same as this, right? Because of course symmetry, you can say that. Distance of S4 is same as, distance of S4 from origin is same as distance of S2 from origin. You can say it by symmetry or by looking at the figure 6a square, correct? Yes or no? So, now we have energy of each constellation point or energy of each waveform. So, what is the average energy of the constellation, and what is the physical meaning of average energy of this constellation? These two questions are remaining. So, first average energy क्या होगा? You have to write 1 by the probability of this S2 का क्या होगा? 6a square.
So it would be 1/4 addition.
So, by solving it, you can say 6a square, right? Yes or no? 3 by 2 is 3 by 2 is 3, 3 plus 3 is 6, so 6a square. So, this is how we evaluate average energy of this constellation, and average energy of this constellation, if you know, you would say what would be the average energy required if you want to transmit this, or what is the average transmit energy? Yes or no? For example, you are having a sequence of bits which is coming here 0 0 1 0 0 0. Sometimes S1t would come out. When S1t would come out, how much energy will be consumed? Even 1 by 4 times, almost 1 by 4 times S2 would come out, almost 1 by 3 times, 1 by 4 times S3, and so on. So 1 by 4 E1 plus up to 1 by 4 E4, and therefore this average energy would give you a idea how much energy would be consumed here. ठीक है? ठीक है, चलो.
So can you show the final answer last slide? Yes, then. Done, sir. Thank you.
So the energy of the first constellation was average energy 2a square, and the average energy of the last constellation was, so average energy of the first constellation, which was something like this, was equal to 2a square, and average energy of the constellation which looked like this is 6a square. So which of this constellation is more energy efficient? First two. But of course, we don't know which one will perform better at the receiver end. We have not discussed this, right? But if somebody gives you a basic hint that the performance of these two at the receiver end in terms of error performance means, for example, you send 1000 bits, ठीक है? So here you have a first way of mapping bit to constellation point. Here you have a second way, right? Now the sequence of bits are generated by a source after the, of course, channel encoder, etc. You are transmitting it and you are also transmitting. I mean, these are two separate systems. So if you come evaluate this system's performance, somebody give you a hint that this would depend upon the distance between the minimum distance between the constellation point. Minimum distance between the constellation point. You understood my point? Abhishek, yes or no? Okay. तुम्हारे पास सीक्वेंस ऑफ बिट्स है 0 1 0 1, तो तुम इसको भेजोगे, राइट? यू विल ट्रांसमिट इट यूजिंग दिस constellation point, or yes or no?
Yes.
Similarly, you will use this in this if you have a second. So at the receiver end you will decode it.
Yes. Same mapping.
Yeah, something like that. But I told you that if this point are close enough, the noise can take this point to this.
Yes.
So the performance or the receiver will confuse. So the better, more the distance, more better judgment at the receiver, right? So performance is directly or inversely proportional to distance, not directly but some function of this, right? Yes or no?
And since distance gives us something, if energy right?
One second, we have to mute. Please mute the someone's mic is making a bit disturbance. Anyways, now things are clear. हाँ बोलो. So the
Gives us energy, right, sir? So that means that is why energy and performance are inversely proportional. Is that correct?
firstly close the mic of other person. Who is that person? I am not able to find out. Venu, okay. Venu P. No, I am not. Venu P is not present here. Okay. So we have muted Venu P now. So, this is the distance between the constellation points, and where f is a monotonically decreasing or decreasing function of distance means. So, the performance will improve if distance is more, or you can say error will be less if distance is more, and where f is the monotonically decreasing function of distance, f is decreasing function of something like that, right. So, somebody just told you this thing, as you increase these distance the performance will improve, correct. So, now I would ask, the energy which you are transmitting here is okay 2a square, here it was 6a square, but here you are giving more power, or you are consuming more power or more battery or more energy. So, are you getting more performance also? So, just look at the distance. So, you will see that minimum distance means, see distance hai na. So, there will be many distances, right, distance of this to this, this to this, this to this. So, we will see the distance which is minimum, right, the closest, the neighbors, we will try to see the nearest neighbor distance, if in other words. So, here this distance is around, I think this root 6a square or root 6a. So, the minimum distance of this constellation of root 6a. So, this will decide the performance at the receiver. This is the something which will decide the performance here, and here which will decide the performance. I think the distance is this and this 2a, right? Yeah, 2a.
Sir, in second one, can we really see the minimum distance is 268? Wouldn't it be 0 before S1?
भाई डिस्टेंस इसके इसके बीच में होती है, ओरिजिन में डिस्टेंस कहाँ से आ गई? डिस्टेंस इज
Point you raised there.
अरे डिस्टेंस बिटवीन टू कॉन्स्टेलेशन पॉइंट बेटा,
अच्छा, okay.
distance between any two constellation point, and we are finding out the minimum. So, these are the neighbors, right, nearest neighbors, these and this. So, we will try to find out the distance between nearest neighbors. I am just giving you how to, maybe the elaborate way we will discuss later, but this is the 2a will decide, and here see root 6a, root 6 is always greater than 2, right, because yes or no, because 2 is root 4. So, this is, so of course you are getting better performance. So, though you are providing more energy here, you are getting better performance, right. So, if you want to compare them, apple to apple comparison, what you have to do? Let 2a square is equal to also some fixed joules, for example 10, you will fix that, okay, let us check their performance at 10 when E is equal to 10. What would happen at E is equal to 10? So, 2a square is 10 or E, so A will be E by 2, yes or no, or let us take it 4, E को 4 ले लेते, no, let us take E as 8. Okay, now you have root 6 a is equal to E. So, a is equal to E by root 6. So, if you make your a like this, now the energy of both are equal, E, okay, इसको रहने दो, let at E. Now what would be the d min here? 2 root E by 2 that is equal to root 2 e.
Why are you taking 2s?
For apple to apple comparison, we say that now we are normalizing or we are making the energy of these two equal. If you want to make this energy equal, for this case A1 will be, A को A1 कर लो भाई अगर confusion है तो भाई ये क्या था आपका A is a parameter right here. A is a parameter for this constellation and this is the parameter for this constellation. So you can tweak this parameter right. भाई ये एक setup है, this is a setup, energy is different. So first make the
Same energy.
right.
You are trying to see what will be the value of A1 and A2. How different?
A1 and A2 will be different and accordingly d min will be different right. So it's better to write like this. So this is A for the first scenario, this A for the second scenario. Okay. Two A square 6 A square. So A will, for the second case you need to make it as root e by 6 right. So for d min 2, d min will be root 6 into A2 please let me know if you have any doubt. A2 this is for the second setup, root 6 into root e by 6. अभी बताओ which will be better. लेफ्ट वाला हो गया ना बिकॉज लेफ्ट में रूट 2 ही है डिस्टेंस. कुछ गलत किया क्या मैंने? या रूट 2 ई इज 1.41. सो मोर द डिस्टेंस better the performance. You understood my point?
How did this happen?
Because here by here the energy was different at the transmitter end. How can you compare these two things? How can you say that your mobile is ultra pro and my is only ultra? So इसका तो पिक्चर अच्छा होगा ही भाई. दो चीज़ें अगर कंपेयर करना है तो दोनों का पैसा भी तो बराबर होना चाहिए ना. When you buy two things at equal price, you compare their performance. So first what I did, I made this energy of both equal. I would use same energy for these two constellation, and if I do so, what I observe that the distance between these two constellation point is actually more as compared to this. वहाँ पर हमने normalization proper नहीं किया था, right? You understood my point, yes or no? Average energy of the second is this, average energy of first is this. You can write it at first and second. अभी clear है? So now first we are making these two energies equal, therefore E1 and A2 same. So I would say either you can compare, I mean, see if A is fixed, the transmission power at the second scheme is more. So the performance is बोलो.
But we compare d min of both of them,
Right.
Respect of energy.
Yes. No. It is related to A1 and A1 is related to energy.
So that is why d min we thought the second one has higher. And
Yes.
that
Yeah. But
normalize.
yes. Correct. So this was the idea, that you should not compare two schemes without understanding whether the transmission power for both are same or not. You understood my point? So this is how I created this example, that you understand it better. Now you understand my point? You cannot compare Apple phone with the Nokia. I mean my phone. I mean, right? I don't have Apple, so Anyways, my point is that you should compare two things when okay, तुम लोग कैसे करते हो in your companies? We have a cost function, right? Something like that.
Yeah, it's clear, sir. It's clear.
It's clear. Okay, चल. So now I hope I have made this point clear. So let's now see BPSK, right? Or any general PSK.
Sir, we just keep the previous slide.
Yeah, please. This is first scheme. So actually your first scheme is better as compared to second. Please make sure that all of these calculations are right, because I suddenly made this example. Anyways, so अभी क्या बात हुआ? Till now we have discussed a very general concept, right? For the third block, that is bit to waveform mapper. But what is the most used or more the generally used wave bit to waveform mappers, or the schemes which are used? Phase shift keying. First let's discuss first phase shift keying. फेज शिफ्ट कीइंग में क्या होता है? फॉर एग्जांपल और m array psk. So if m is equal to 4, what does it mean? 0 will be sent through cos of 2 pi fct plus 0. One possible mapping, one possible something like that. First of all, what do we mean by phase shift keying? Abhishek?